A primary goal of many general education courses is to foster scientific literacy among students such that they inform their judgments and choices with evidence. However, most students do not generally begin evidence evaluation from a neutral position. Rather, they are biased by whether they want to believe its conclusions. When a student holds directional goals, they are motivated to arrive at a preferred conclusion, despite contradictory evidence, while a student with accuracy goals is motivated to be accurate in their conclusions. Therefore, the primary goal in this study is to foster accuracy goals in students, as well as teach them how to engage in accuracy-oriented reasoning, or the evaluation of evidence with the intent of being accurate in one's conclusions. The purpose of this poster is to share the structure of pedagogical materials we've developed in the context of this study, as well as generate discussion about how they could be improved and adapted to new instructional context. These tools include issue problem sets and a voting scenario. We developed 3 problem sets on immigration and economics, safety of GMOs for human health and the environment, and bottled water quality. As shown in Figure 2, students were prompted to work through a series of tasks that involved stating preconceptions on the issue, analysis of biased websites on the issue while being reminded of media literacy strategies, discussion of evidence regarding the issue with peers, and revisiting one's preconceptions feedback. To evaluate whether the learning experience fostered accuracy-oriented reasoning, a pre-post assessment was implemented at the beginning and at the end of the course. This assessment included a public policy voting scenario on a controversial topic, which was whether federal government should relax regulations on greenhouse gas emissions from coal-fired power plant or not, as shown in Figure 3. Students were presented with supporting evidence of pros and cons that included factual-based and opinion-based from credible sources and non-credible sources. Equal number of pieces of evidence of factual basis versus opinion-based and from credible sources and non-credible sources were presented for pros and cons. The page length was the same for all pieces of evidence by screenshot of key information. Students' interaction data, such as when a piece of evidence was clicked and how long a student stayed on a page and so forth, were captured. Lastly, students were asked for their voting decisions and reasonings of their decisions. In addition, we also asked students to identify specific aspects of the classroom culture that facilitated productive learning, such as valuing dissent, valuing mistakes, amiable disagreement, and the degree to which their basic psychological needs were fulfilled in the course, because need fulfillment is a precursor to motivation towards accuracy orientation. Now, what did we find? Figure 5 shows how students spent time on credible versus non-credible pieces of evidence according to whether or not they changed their decision in the public voting scenario. Qualitative analysis shown in Figure 6 and Figure 8 indicated several students, about 20, made directional shifts in their voting scenario answers in both positive and negative directions. Positive means switching from an uninformed to informed responses based on credible sources, and negative means switching from informed and accurate response to non-credible, uninformed response. In the positive direction, students collectively focused on economic aspects of supporting coal to a shift in concerns about the safety and sustainability of coal as a longer-term energy source. Students with negative directional shifts centered on the concerns with coal but changed to supporting the necessity of coal due to the ideas of the benefits being greater than the risks. Also, the changes in the accuracy-oriented reasoning varies from semester to semester, as shown in Figure 7, which shows the data from fall of 2019, in which there was unfortunately a decrease in accuracy orientation. In the future, we seek to identify ways that we can better measure the construct relates to motivated reasoning, such as accuracy orientation and directional reasoning. Nevertheless, asynchronous discussion boards are very effective in helping students understand topics where common misconceptions or ignorance exist. Controversial topics where people care about its conclusion, such as climate change and immigration and economy, are great opportunities to study and cultivate students to begin evidence evaluation from a neutral position, a key component in scientific literacy. Future research might involve observation of in-person problem set discussions and evidence evaluations to better understand when and how students shift in reasoning.